Oh, speaking of like weird clicking sounds like that. So I was at lunch today and I got a text from my wife. Apparently, my niece's high school, which is like in the sticks in Illinois, like little tiny places, was like on lockdown because they found a live grenade in the gymnasium or something.
What?
They were bringing, huh?
People there get their hands on grenades.
I don't know, but I don't. I
Can
guess
you
it,
let me know where they got the grenade
I guess
from?
I guess it's fine now. I don't know if they brought in the bomb squad to take their grenade out or something. It was like a rusty pin. All right, so last time we were talking about. Shut up! It's just extra bad because I'm getting this babble and I'm getting foreign language babble. Oh yeah. All right. So we were talking last time about cable modems versus DSL. Remind me, why do cable modems? Why did early cable modems need to have a dial-up modem as well?
They couldn't do upload. There's only
No upload.
requests.
Okay, because these guys were designed to be a broadcast type system. So we were talking last time a little bit about high definition TV and the amount of data that needs to go over the lines in order to support this. Even at compression levels, we're starting to run into situations where we can only have a finite number of HD shows showing at the same time. This actually becomes kind of an interesting concept with modern technology. Several years ago, high definition TVs were the latest craze. Now, if you're going to shop for a brand new TV from our good buddy here at Best Buy, you can get a 1080p TV, either LCD or LED, and you're looking at Hertz ratings and crap like that. And now they're going to start pushing on you these 4K TVs, ultra high definition TVs, right? Okay, so 4 times the resolution of standard HD. Problem is that there are very few, if any, sources today of 4K content. And don't hold your breath for us getting 4K content given to us over either the cable companies or any of the dish network companies anytime soon. That's a lot of data that has to move at the same time. Go ahead.
You also realize you're in Best Buy, so you walk out and realize.
Sometimes Best Buy has some pretty good TV deals.
Well, the best thing to get is one with the 240 motion clarity in it.
Well, why?
Because when it upscales even 720 or 1080 content, it looks better and it's clearer in the motion.
Well,
clarity.
it's smoother.
Yeah.
But the question is, can you see the difference between 120 and 240?
Oh,
I might argue that you can't. I think you can see the difference between 60 and 120.
I think you'd most notably see the difference just because there's the motion stuff. Like that alone
the motion
helps
clarity.
a lot.
Mm-hmm.
But yeah, the 240 obviously.
Yeah, I could see that. But certainly going to the higher resolution, I don't think pays today because you're going to pay a premium for a 4K TV when you could buy that 4K TV for a lot less money when there's actually 4K content out. But in any case, from our perspective in here, dealing with networks, if we're talking about utilizing the the coaxial network that the cable company has, we're dealing with sending these bits of data, in this case pictures and sound, across that network, and there's only so much bandwidth to go around. So last time at the end of class, I think I mentioned something along the lines of I want us to start thinking about networks as being more than just internet. Okay, they're communication channels between multiple computers, and we can use those for a lot of different things. Okay, let's see. So as an example, this might be our home network type dealie, where you have some sort of device here. Maybe this is your cable modem or your DSL modem or your satellite dish or your Wi-Fi network router thingy. So you have a box. If this is your internet, this box is your source to the internet, which is coming into your house and being shared through all these different computers. And we'll talk about some of this equipment here in a second. If we're dealing with cable TV, this box is the cable TV receiver coming into the house, which then plugs into a television. Some of the new ones have the cable comes into the house, plugs into like a multi-room DVR type thing, and then at least Uverse, I think DirecTV has it now, and everybody's going to have it pretty soon, has the wireless cable boxes that what do the commercials say? You don't need the TV outlet. I've never heard it called a TV outlet until those commercials. But whatever, you can put the TVs wherever you want because the boxes are wireless. So in our house, we have Uverse for television. I have Time Warner for internet because I won't deal with crappy internet like he does. You have Uverse, right? Yeah, so in any case, so for Uverse, we have a single DVR box that has a giant hard drive on it that can record a bunch of shows. And then we have 3 other wireless boxes in the house for that kind of stuff.
Why don't you just get cable from or TV from Time Warner?
Had TV from Time Warner before that. Uverse had better packages for what we were interested in. And on top of that, if you've ever had Time Warner cable or either really any cable company that I've dealt with, the menu system is really, really slow. So the boxes are very old technology. Uverse, the menu system in many cases is actually too fast for humans. So, I mean, I've been pretty impressed with our Uverse. Haven't had any problems with it and that kind of stuff. But that's the answer to that. You know, it cost us less money to go to Uverse, and we got more of the channels we were interested in without having to pay for channels we weren't to get those channels. This was the punchline. But I still wasn't willing to give up the internet speed. Somebody would have to be offering something pretty special, I think, for me to go away from Time Warner cable in this area for internet. I'm getting 100 megabits per second, and you're not getting that. You're not getting anywhere close to that through any other provider. Well, yours is through cable as well.
Yeah, through
Yeah.
Time Warner.
Yeah.
Megs.
So any other provider, the maximum you're going to get will be nice and say 20, but it's not going to be 20. It's going to be less than that. So I'm getting 5 times the speed I get with, 5 times the bandwidth, total bandwidth I get with anybody else. You know, that allows me to have all my bots running. I can have files downloading in the background. I can be watching Netflix in my hot tub. I do that. I hung a big screen TV. I put a hot tub in my garage. This is I'm recording too. So I put a hot tub in my garage so that I wouldn't have to wear as many clothes. And
don't worry, I put up line.
So, and I hung a big screen TV from the ceiling so I could just sit in there and watch Netflix. And since I don't have a clock, you need to install a clock out there.
Do I? Clock? Digital or analog?
I can't read analog.
No.
Yeah, my wife can.
Do you want me to put it on a timer? Just a buzzer?
Buzzer. Well, right now I do all my timing based on length of shows on Netflix.
We
So I stay in the hot tub for either 43 minutes or 86 minutes.
We could do
One or 2 shows.
We could do it like your office, put the TV on a Christmas light timer.
Seriously.
Real simple.
Yeah, it's really bad. We were talking at lunch today. Here's an out of context statement. This was it Tuesday? Yeah, Tuesday. What's today?
Today's Wednesday.
Oh, you were at my house last night.
Yeah.
So he was in my bedroom last night sewing. That's for our out of context, creepy comment on video on recording. He's helping me fix a massage chair in my house, and apparently he's a seamstress. So,
I have a lot of skills.
So, in any case, regardless, and this kind of goes along with what we were just saying a few minutes ago, whether we're talking about internet, whether we're talking about cable television, or really anything else that requires data to be transferred between multiple places, you have a starting point. This would be like the edge router I've referred to here on campus. Okay, this is the source of our data coming into our house, whether it's TV or internet. From there, we want to distribute that data among the different devices inside of our house. So we usually have this piece of equipment they're pointing to it saying router, firewall, NAT. Anybody know what NAT stands for? We'll be talking about it in here, but anybody know right off the bat? Huh? Yeah, I mean, that's right. Do you know what it stands for?
Is it network address translation?
Yeah, network address translation. So for those of you who have routers at your house, Wi-Fi or even a wired router, but most routers anymore have Wi-Fi and wired. When you're getting an address like 10.0. something or 192.168. something, that's an internal network that's using network address translation to make the request on behalf of one of these internal machines, because the only machine in the house that has a real IP address from your cable company's perspective is this router right here. So this guy is a computer. He gets a real IP address that then accepts requests from all these other machines in the house that have non-real IP addresses. And this guy makes the request, translates it for who it came from, and then sends it back, routes the result back to the right place. So that's what a NAT is for. And we'll talk about that in a lot more detail. Okay, and you can notice this is, we have an official, this is an older school setup here. So this would be a hardware wired router that we have a wireless router plugged into. So we'd have two physically separate networks, one for the wireless devices, one for the wired devices. Where today, most of these things are one device. Do you have a question? Or was that what you were going to ask?
I was going to say, for the home NATs, does it have a different IP addresses like everyone?
Yeah, each of these machines has to be unique on this network, on the internal network. But for instance, this machine might be 192.168.1.7, and I might have a machine at my house that has that exact same IP address. The machine at my house is unique on my network. The machine at your house is unique on your network. But they have the same IP address because they're referred to be as they're non-routable IP addresses.
So does each that NAT make have one routable number?
Well, it may or may not be routable. It depends on what this guy's handed out. Because this guy might be on his own NAT. So your cable modem, in this case, it's going to hand out an IP address. Depending on who your provider is and what their setup is, it might be a routable IP address. Or your actual router, your machine that you have plugged into the cable modem might get a non-routable IP address. Because your network is actually part of a NAT-based network at the cable company. Yeah, so all you can see is your little world, and you're part of a bigger world. That's how networks work. But you're kind of at the mercy of how they are set up. Okay? So, cable modem or your cable TV box, whatever. Now it's distributed amongst all the things in the house. So we have a couple of desktop computers here, a laptop through Wi-Fi. I'm thinking that's an iPhone, right? Looks like iPhone-y stuff.
iPhone 3GS looks like.
Well, how do you know it's a GS instead of just a 3G?
I don't know. It looked like Siri. It was talking.
3GS doesn't have Siri.
No.
4S has Siri.
4S, Siri.
This is the crap you get at Best Buy.
It says
They
mobile.
act-
You
on
have to
my
have him
shirt.
locked in a bedroom somewhere sewing. That's what he's good for.
We're Best Buy. We don't deal with that old ass technology.
Don't you still sell 4Ss?
Yeah, for $150 outright.
Yeah, see, it makes sense.
Like I could. They're not even worth it.
All right, so this is an example of our home network we might set up. So enterprise access networks, whatever. This might be at a little bit more professional level, something we might see here at Concordia, for example. So we have, they're calling this an institutional link to the ISP or to your internet. So we are buying bandwidth from somebody. Okay, here on campus, we probably have a couple of different bandwidth providers. The telephone company's providing us probably something, and then we also are probably getting it from another source. So we have a failover, so we don't ever have a complete outage. Well, hopefully our complete outages have nothing to do with whether or not the internet is being delivered to the university. Outages for us tend to be more internal congestion with our network and network attacks and that kind of stuff. Okay, so right here we have this is equivalent to the cable company hooking up the television signal or the internet to your house. Okay, just at a commercial level, we're probably getting better, well, you hope it's better bandwidth. Does anybody know what Concordia has as an inbound pipe? They might not have 100 megabits. I might have better than Concordia. But theirs is probably synchronous, so it's the same speed up and down. But whatever, doesn't matter. All right, so in any case, so this is the incoming internet. So all communication leaving campus goes through this. That's hooked up to, they're calling this the institutional router. I've referred to it in here as our edge router. Okay, this is the piece of equipment that sits between this university and the rest of the world. Okay? From our network administration perspective, the guys here on campus, IT, whoever, Mark Newhouse would be in charge of this stuff. From their perspective, what they have control over is this machine and in. They don't have control over what's happening at whoever the source of their internet is or somewhere else on the internet. That makes sense? This is his world. All right, so this is our edge router. I don't really like institutional router, but whatever, doesn't matter. So this is our edge router. Now in this little example, we have two separate subnetworks. Sometimes they're called subnets. So these are Ethernet switches. Okay, and we'll talk what a switch is here. I'll probably end up talking about it now anyways. But so what a switch lets us do is it allows us to have more than one computer hooked up on the same network. But a switch does not hand out IP addresses. All right, so I'm getting a little ahead of myself. I don't want to talk too far into that. But bottom line is these machines, these are two servers. So this might be the Concordia's web server, and this might be Concordia's email server, although I think we switched over to Office 365. So I think email's off campus now, but whatever. We have big, beefy machines here on campus that perform services. We have a server for Angel. I think Blackboard's going to be hosted locally as well. Whatever. And we might have 10 or 12 different services across 2 or 3 different physical servers. So each one of these machines doesn't only have to offer one service. It depends. Okay, but these are our server class machines. So off this edge router, we have a switch in our server room. So this would be down in IT somewhere. And inside there, we have our expensive, larger computers with more capacity, with backup equipment and all this crap hooked up to it. So you'd have a little local network here inside that server room where all of these guys can communicate with each other very quickly. But they're still part of this larger network here on campus. Okay, because the bridge, the central point is the edge router. All right. Secondarily, we also have this other switch. So we might call this, let's say this is computer science. Okay, so in computer science, we have a switch coming to us. So we have access to, we are a client as a department, let's say. We are a client of this router. So this router has handed us an IP address or the ability to hand out other IP addresses. Here on campus, we typically have routable IP addresses. It's actually not uncommon for universities when we actually talk about IP addresses in more detail. Way back when the internet was first kind of becoming a thing and we were dealing with connecting to the outside world, places like universities and enterprises, they would request a block of IP addresses based on how many machines they anticipated needing unique IP addresses for. Unique phone numbers, if you will, which is what IP addresses are. Based on that, Concordia was awarded a block of IP addresses. So maybe we have 5,000 IP addresses that were given to us, whether we need them or not. So those were taken off the market. Nobody else gets those 5,000 IP addresses. Okay? This is kind of the reason. How many of you have heard of IPv6 versus IPv4? I can just throw it up here real quick. This IPv6 versus IPv4. These guys right here. Okay. IPv6 is the newer technology. Hardly anybody uses it yet, but it's starting to become more of a standard, or you're starting to see networks that are interoperable between the two. Punchline here is that with IPv4, there is a unique number of total IP addresses. That is, with an IP address, you have 0 to 255 dot 0 to 255 dot 0 to 255 dot 0 to 255. Those are the range of IP addresses that you can have. And there's some illegal ones in there as well, but let's just say that covers the gambit. Okay, well, that's not an infinite number of unique IP addresses. Make sense? So given that, because now every computer is on the internet, and by every I mean almost every, correct? So given that, we started running out of IP addresses. That's why we started having things like network address translation coming into play, so that internal homes didn't have to request real IP addresses. Okay, so we started running out of total IP addresses, so IPv6 was created to give us more IP addresses until we run out of those. Just like anything else, right? Okay, so not that important right now, just kind of more trivia stuff that came to mind. All right, so this is computer science. So computer science is given a direct link to our router. So we are given the services from the external internet as well as the services from our servers, because these guys are both linked to the central network that is Concordia's network. I still call a network like Concordia a local area network. Books might call it a municipal area network, a MAN. Wide area networks typically are considered when you leave one place and go to another place, not leave one physical address and go to another physical address. If it's in the same town, that's where I might call that a municipal area network. But for me, it's LANs and WANs, and really a WAN is just a gigantic LAN.
You say WAN.
Was that freezing? Oh, it is now. Okay. But you get what I'm saying. Everything's relative. There's no difference between a local area network and a wide area network. It's the same model, just we call it a wide area network because it's across a larger landscape, a larger region. The same crap. And we might use some different tools for connecting networks to each other, and we'll talk about that as well. So for instance, we probably don't want to have to run an Ethernet cable from Concordia 200 miles to south side of Chicago. Right?
I want to see this.
That's not something we want to do. We have to have other mechanisms to connect us to other parts of the world. Something like that. Or if you want to make it really bad, we're certainly not running an Ethernet cable to Moscow. But we could all send email addresses to the University of Moscow. Moscow's in Russia, by the way. I saw a couple of glazed overlooks.
Where's Russia?
Where's Russia?
Big ice chunk over in Asia.
That would be Siberia. Actually, there's some really nice climates in Russia. Some of southwestern Russia is like on some water with it's like a vacation destination, like Sochi. Sochi, Russia. Sochi, Russia. Down the mountains is actually kind of a resort destination. Up in the mountains, they shouldn't have people.
What is that? Is that a cat?
No, it was I know what you're talking about. But for Sochi, it was, didn't they have feral dogs was the problem in the region. They had wild dogs that were like getting into some of the Olympic venues and stuff like that. Okay, so in any case, this might be computer science. So here in the department, we have a switch, and off that switch, we might have a bunch of machines. So these machines might be down in our computer lab there at the end. So these are all our iMacs. Then we might also have, I think we have a top secret wireless network in here. If not, we have a wireless network that's given to us by campus, whatever. But there's a wireless network in here as well. So we have some laptops and phones and crap like that connected to that. So kind of an example of a, larger local area network, maybe.
Go back to this top secret wireless network.
So I think we have. You sure?
No, well, if it is, it's a secret.
Oh, I thought we had something. I have access to all the best wireless networks on campus. Okay, she doesn't have the passwords. Res Hall just sits there. Just me and Mark Newhouse.
I gotta hold your massage chair hostage for the password to Res Hall.
No, see, I don't trust the kind of stuff you'll do on the network, so I can't give the passwords out to this.
They're just gonna think you're searching for goat stuff.
Well, that's what, because that's what I want. All right. So, in any case, so this is saying, typically used in companies and universities, blah, blah, blah. Transmission rates, 10 megabits, 100 megabits, 1 gigabit, 10 gigabits. So that deals with the transfer speed within some of the subnets here. So these machines might be on a 1 gigabit or a 10 gigabit per second switch, which means these machines can communicate with each other if they're on a 10 gigabit switch, they can communicate with each other at 10 gigabits, but maybe this guy is a 1 gigabit network. So that means communication between this network and this network can only happen at a maximum speed of 1 gigabit. Maybe this network is 100 megabits. So these machines can only talk to each other at 100 megabits, that kind of stuff. Okay? And these are typically done through a technology called Ethernet today, and we'll talk about that more in detail as we start looking at some of the older topologies, Ethernet versus Token Ring versus ArcNet, like ArcNet.
Apple TV, that's open.
All right, so wireless access networks. When we think of about our wireless networks, really it's Ethernet delivered wirelessly. Okay, the technology works very similarly, except instead of it traveling over the medium that is copper wire, or I guess I suppose fiber optics in some of our more modern networks, it's traveling over the airwaves using radio signals. Other than that, it's the same technology. Okay, so, and this would be kind of what my guess is something similar to what you have over here. So a wireless local area network would deal with these, these routers. Like we have one up in the wall in the other room there. Is there one in here? Yeah, there's one right up there. That little white box with the blue light on it. So those would be a wireless access point. And they're probably based on one of these technologies. This is a little bit older thing. So either 802.11b or G. Do we know, do these support 802.11n? Or are these older than that? These might support N as well, which is about 400 megabits max speed shared. But wireless B was 11 megabits per second. Wireless G was 54 megabits per second. To give you a little bit of background on this, in the early days of Wi-Fi, when it first came out, we had 802.11a and B. These are IEEE standards. The 802.11 standard is an IEEE standard, IEEE. That guy, which is one of the two big standardizing bodies in computer science technology. The other one is ACM, Association for Computer Machinery, right? Yeah, close enough. Okay, but IEEE tends to be our big standard, so the IEEE standard for Wi-Fi is 802.11. The original standard was A, then they had a standard called B. So 802.11a had a maximum speed of 54 megabits per second, but a range of 6 inches. That might have been phrasing. 802.11b was 11 megabits per second, but had a much larger, much bigger range. So you could have an 802.11b router set up in a wireless access point set up in an area and share it amongst a big room or even an area of a building or something like that. Where 802.11a was much faster, but really required you to be much closer. They're saying 100 feet, but I think it's closer than that. 802.11a was really for like me communicating with you, sending stuff wirelessly, that kind of thing. So 802.11g was the best of both worlds. The speed of A, but the distance, the range of B. Okay, so that's where our 802.11g comes from. That's 54 megabits per second at the range of B. All right, N, 802.11n is even faster, about 400 megabits per second. Then you have some of these newer technologies where they do multiple channel routers where they actually have two 400 megabit per second channels. So technically you can bridge across 800 megabits per second if the moons align and that kind of stuff.
4 gigahertz and 5 gigahertz.
Well, yeah. So in any case, the early days is really our best example of this, where the early wireless networks were for close range, relatively fast connection. And then we started seeing there was a need to have devices that weren't hooked in through an Ethernet cable. And we see that's kind of won out. If any of you in here have a newer laptop, you might not even have an Ethernet port in your laptop. So I don't. You don't have one.
I have the adapter though.
Yeah. Right, you get a USB adapter, right? If you needed it, but it didn't come stock. Who in here does have an Ethernet port in your laptop?
Oh, my laptop at home.
Okay, so a little bit older laptop? A little bit older? Anybody have a newer laptop that has an Ethernet port in it? Did you purposely buy it for that reason?
No. Just have it.
just has an Ethernet port.
It's Lenovo. Most Lenovo's do.
Okay. Oh yeah, because you're going.
Collapsible.
Yeah, you're going into network or going into enterprises a lot with those. So punchline is that anymore our goal with machines is to make them thinner and stuff, right? So all of a sudden you have taken yourself out of having Ethernet. Actually, there's something that has fallen to the wayside. I don't think they exist at all anymore. No, not that. Have any of you ever had a machine that had a PCM CIA slot in it?
I know those.
Man, I
Long
forgot. When did they stop
ago.
existing?
Long ago.
Looks like kind of a credit card.
Yeah.
So it almost looks like a credit card.
You get a
But
wireless
I
one.
used to have a laptop that my Ethernet thing, my Ethernet attachment for it was through a PCM CIA slot. So you put this little credit card thing in, and then on the end of it, it had like a spring-loaded thing where you'd push it in, and it would pop out the plug for you to plug the Ethernet cable into.
I had one of those.
I forgot, when did those die?
It got to be what 02, if not earlier. Because I had an older
laptop with one when I was in middle school.
Yeah.
Yeah.
I had an old one with.
Because the punchline with those is, when we were making the transition from desktop to laptops were always considered to be weaker machines, right? I mean, that was the trade-off. You gain portability, you lose performance. Now, one of the nice things we had with desktops, though, is we could upgrade it. We could add sound cards, add other things like that. Well, laptops have never been very upgradable. Even today. I mean, even today, you're probably not upgrading a graphics card in your laptop. There was a couple of different technologies that came out that tried to mimic or allow you to upgrade some stuff on laptops, but it never really worked out. So I think that PCM CIA stuff was all about being able to buy some peripherals, some things that would plug into your laptop to allow you to expand it to something.
Yeah.
Go ahead.
Would you use that technology for like Wi-Fi cards?
Sure.
As well?
Yep.
They had Wi-Fi cards, sound cards for it.
And really, probably the thing that killed it off was USB. Now that I think about it, why do you need a PCM CIA slot that's relatively well? First of all, it's going to add thickness to the laptop because there's got to be hardware in there for the plugs. Most of them had 2 PCM CIA slots, so that's going to make it already a thicker machine. And then on top of that, it's kind of a proprietary technology, whereas USB is open. So, just interesting. I'd forgotten those even existed.
When was the Dell Latitude C600 made? Because that was the last laptop.
Tell me what lap.
Well, that was the last.
What was
laptop.
a C600?
That was the last laptop that I saw that had a PC. Had that.
Oh,
board in
okay.
it. Yeah.
What speed processor was in it?
I don't even remember.
That's
I remember
that-
the exact
I
name
can make
of the
it-
laptop.
What year did XP get released?
Quiz time.
2001.
And I would say it was before that because the machine I had was probably not an XP.
Well,
Didn't
yeah.
stock come with XP on it, but we upgraded it and it had the price slots on it.
Okay.
My
So that's about
C600
the time.
came stock with XP.
Did it? Okay,
Yeah.
well that's about midnight.
But I think
would say.
yeah, I'm pretty sure that, like C600 was the last run, the last hurrah.
I once had a 33 megahertz laptop.
What was the point?
So it was a 386 SX 30. Actually, it was 25 megahertz. 386
Oh,
SX 25 megahertz laptop with I think it was 256K of RAM.
How big was it?
Oh, huge. Yeah, probably maybe at least twice the thickness of his laptop, and it only had a 12-inch screen on it.
I got a computer for my laptop.
I got a computer for my laptop, but my laptop computer.
My grandparents ones that had 256 megabytes of hard drive space.
Yeah. In 1996,
I was 5 years old.
I had this really a bleeding edge computer. It was an IBM desktop computer, and it came stock. I had to wait for the processor to be released. It was a 486 DX2 66 megahertz processor. It was the first chip that had a math coprocessor on it. That means your processor also knew how to do math. Before that, those were 2 separate chips. Those are two separate chips, and it came with it shipped with a 420 megabyte hard drive, and 8 megabytes of RAM.
That's huge.
A year later, I upgraded the RAM to 16 megabytes, and that cost $1,000 for an 8 megabyte RAM upgrade. And I upgraded the hard drive. I wanted to have a gigabyte hard drive, so I put a 540 gigabyte or 540 megabyte hard drive in it. It was an IDE based hard drive. Set that up, and I think that was another 1,000, or something like you accidentally get today.
You
but
also the friend that set his desktop on fire. You've had the computer adventures.
that's true. Yeah, you've heard that story, right? The fire in the dorm room. That was a good one. It was.
I've heard.
Oh, a couple of you haven't. So, when I was in undergrad, one of my buddies down the hall. This was back when Intel had these budget pleaser chips called Celerons. They were it was the same time as the Pentium 2 processors were out. So you had the Pentium 2, which was their good one, and then you had the Celeron, which was like budget pleaser to make it cheap. And there was this whole big hobby in overclocking Celeron processors. So this dude had like I think it was 166 or maybe it was a 200 megahertz Celeron processor. Overclocked to like 1.2 gigahertz. And you go into his room, he has like all these fans pointing into this case. And so I'm in my dorm room one night, and I always sat there and programmed overnight, and then I kind of had the door open to my room. And all of a sudden I hear like just like sprint running down the hall. And he's yelling. So I come out the door. And I'm at one end of the hall near the elevator. He's all the way at the other end of the hall on the left side of the hall. And there are flames billowing. I mean, it looked like his room was hell. Okay, we're not talking a small fire. Okay, his entire dorm room was engulfed in flames. It was awesome. Oh, and then of course we had to share the cost and the floor of the damages. Totally worth it. So kids, don't overclock your processors by that much. If it has a CPU rating, overclock by like 10%, not 500%.
You can install it in a refrigerator.
Well, actually, there was some really cool stuff like people who would do a lot of overclocking. They used to submerge their machine in liquid ether, which is an inert liquid.
Yeah.
So, and like, what was the point? It's like, why don't you not buy the budget pleaser chip and just get a better processor?
But I need this $500 worth of ether.
Right.
I'm saving 5 cents.
I don't think I've ever told you guys this one. But during the whole ether time period, a buddy of mine had a friend who interned with one of our early startup companies, and when this guy interviewed, he was an assistant mortician. So when he's interviewing, we were asking about problem solving and stuff like that. So he goes into this detail about this one person he had to make look presentable for like basically somebody looked like Frankenstein, and they had to make him presentable for a family. So he's using that as an example of problem solving. Okay, first of all, well, anyways, he was this dude's source for formaldehyde, which he was using as a liquid coolant for his computer. I think you guys understand now what's wrong with me. I ran with some strange crowds.
Strange. That sounds awesome.
I hung out with a mortician, and the dude who was paying him under the table for formaldehyde.
Do you still know him?
I don't. To be honest, I don't remember his name.
Can you still get a hold of?
Probably. I guess maybe.
Don't ask questions.
All right, so let's cook through a couple more things here. All right, so we have our home-based wireless things. Then we start dealing with more wide area wireless stuff. Most of this is from our cellular operators.
GSMU, MTS, and LTE.
Yeah, and even this isn't really accurate anymore, 1 to 10 megabit per second. So 3G, 4G, LTE, even within these technologies, 3G is really it talks about a generation of technology, not a specific technology. So prior to 3G, we would have had, what was called 2G. Really, probably the first one you would have heard of. Some people were calling it 2.5G. This was a GSM-based network that AT&T called Edge. Except spelled differently than that.
I can tell you everything about AT&T cellular tower.
All right, so this was their old technology. Now the reality is at the same time as that was out, you had a 3G technology, which was, we'll say this was on Verizon. You had Verizon and Sprint both used this technology. And this had up to a maximum of 3 megabit per second. Probably not realized, but a maximum from a technology perspective of 3 megabits per second. Where Edge had a maximum of about 200 kilobits per second. Okay, so just to kind of put this into our time period, the first iPhone that came out, was on AT&T's Edge network. Okay, because AT&T had the exclusive. And kind of a little, I don't know if it's a little known fact, but did you know that Apple went to Verizon first? Interesting backstory. Apple went to Verizon first and offered them the exclusive on the iPhone. Oh, you guys are Apple. What does Apple know about cell phones? Turned them down. So they went to AT&T, and that worked out all right for AT&T.
They've been kicking themselves.
Yeah. I mean, really, before that, AT&T was nowhere near the size of Verizon in terms of a cell phone company. So, in any case, the first iPhone came out, it was on their Edge network, which is considered fairly slow. And that was really a problem in the early days of the iPhone. In fact, had Android been out at that time, I think Android would have taken the lead very quickly. Because Android being an open system would have been on these other carriers. And let's call it the real competitor to iPhone as opposed to like the Windows Mobile and Palm and stuff like that. If you're on Verizon's network, you're going a lot faster for your mobile data than you were on AT&T's Edge. And part of this was AT&T had an early gamble on a technology called GSM. Verizon went with CDMA because Verizon wanted to be one of the early, Verizon and Sprint really, wanted to be one of the early providers of data to cellular customers. And the only way they can get data at any sort of speed that seemed reasonable was through a technology called CDMA, which is a cell division multiplexing thing.
Nightmare to us.
So the punchline here is that CDMA capped out at that. It really never passed it, even with some compression. Didn't go past it. GSM, over the years, finally caught up. They hit 3 megabits per second. If you remember, the second iPhone that came out was the iPhone 3G. So it worked on AT&T's 3G network. And their 3G network was about 3 megabits per second. Very quickly, it became 6 megabits per second, went up to about 12 megabits per second. You might even say 12 to 15, but it's somewhere in there. GSM had a rollover to something you've all seen today, probably called LTE. Okay? So now, it's not necessarily uncommon. I've seen LTE speeds on AT&T's network here in Mequon at about 60 megabits per second. And there's places where it goes even faster than that. And you've probably noticed if you are a Verizon or a Sprint customer that they're all diving over to LTE as well, right? They have dual bands in them right now, so they still function on some of their older CDMA networks, but everybody's going over to LTE technologies, which are GSM-based technologies.
That's why you can take your iPhone 6 and use it on
All right, so that's kind of the history of these networks here, and GSM kind of won out, but it was by far the slowest for a long time. Wasn't anywhere near the speed of some of the other ones. All right, so that's the 3G. 4G kind of was in the running in here. Maybe 4G was that 13 to 15 megabit per second thing. Punchline here is that you can't say, well, AT&T's 3G is the same as US Cellular's 3G. They're not the same technology. Okay? They were both called 3G, but you're not comparing apples to apples. That makes sense. So these terms here mean very different things. Even LTE. You really want to, LTE I think you can treat as almost a standard. It's a GSM-based standard, but think of this as our Ethernet cable. Okay? It's going over the airwaves. It's using this technology for sending data. You are still at the mercy of how much bandwidth is being provided to that network. Does that make sense? So if I'm here in Mequon and I was getting 60 megabits per second on a speed test, let's say, that doesn't mean that I will go to Chicago and be on an LTE network with similar capabilities, but get a much slower speed, just because of the amount of traffic that was currently on the network and stuff like that. Does that make sense? All right. Just see where we're going next here. Okay, so on Friday, we'll come back and we're going to start talking about packets. That is, how do we put stuff in a nice little Ziploc bag before we throw it onto the network? Okay, because we need to be able to rebuild things from these packets. All right, I'll see everybody on Friday. And let's see, was there any good quiz questions in here? There might have been.
Still waiting
AT&T's
for
middle
bots.
network was their 4G network was actually.
Oh, I think I might be able to come up with a good quiz question based on what we talked about today next class.
Which friend provided the formaldehyde?
Who is the best seamstress in class? Maybe not best. Best might be
Adequate.
objective. Yeah.
Adequate.
Who is a surprising seamstress in class?